Hi. So today we're going to learn about the identification and preservation of fingerprints. So there are going to be three main types of crime scene fingerprints. Here, let me move this down here. Okay, so there are going to be three main types of crime scene fingerprints. The first is going to be visible prints. And the word visible sounds like exactly what we mean by that, right? You can literally see them without any help because of how they were made. They were made by touching some sort of colored material, usually a liquid like blood, paint, grease, or ink, and then those fingerprints ended up being on some sort of material at that crime scene. They are very visible to you already. There are these other prints called plastic or physical prints where they're sort of physically embedded into whatever the material is. So impressions of the ridges of the fingers are embedded into a soft material such as a putty, a wax, soap, dust. Like, for example, if there was a melting candle wax or something like that, or something was soft and while someone was touching it, that might have left a physical print. We will specifically be working with latent prints, which are sort of what you think of when you think of fingerprints. They are impressions caused by the transfer of perspirations or oils from the tips of your fingers onto an object, right? And so you need to develop these. You need to make them visible. The others you could probably see without any special techniques. The latent prints, you need special techniques in order to see them and then in order to preserve them for analysis. This picture is again sort of a cross-section of a part of a finger with the skin there, showing that you have these ridges and you have sweat glands here down at the bottom coming up through a duct and out right where your fingertips are, where those grooves and ridges are. And so these will create sweat, create oils, and those are the things that are left over on some sort of surface. So one of the techniques you can use is going to be dusting. This is going to be most suitable for hard or non-porous surfaces. And what do we mean by non-porous? That means if you were to put, like, for example, a drop of water on it, that water would not be absorbed. It would stay on top of that surface. It does not have any pores in it. So examples of that would be glass, tile, plastic, metal, something along those lines. And the idea is that the dust from the fingerprinting will adhere to the sweat and oils left behind on that surface, and then that fingerprint will be made visible. So one way to do this is you have special dust for fingerprinting. You cover the surface with that dust. You remove all the excess because you only want what is stuck to the fingerprints to remain, and then you will use tape to lift the print. And we will be doing a lot of this sort of fingerprinting or fingerprint retrieval and analysis using dust in our lab, right? This is something like how it would look, and you could put it on a card and take data from that, catalog it. You're definitely, every time you get fingerprints, you're going to want to know, okay, where did it come from? Where was it in the crime scene? And additionally to identifying whose print that was, what hand it was on, what finger it was, all of those sorts of things. Another way to do this, another technique is iodine fuming. So we're using the chemical iodine and using the gases from that to get the fingerprint to be visible. So this is going to be suitable for soft, porous. So again, there's pores to this, and also non-porous surfaces. But things like paper would be ideal. Index cards, magazines, some cardboard, we would use this sort of fingerprinting. The idea here is that when placed with the iodine, the vapors that come off of the iodine crystals will be absorbed by the sweat and oil that exists left over from that fingerprint, and it would allow it to turn a color. So the way that this works is you have your object that theoretically has a fingerprint on it. You put it into a closed chamber because you're going to want the gases to be there. And this is going to be left with iodine crystals that are going to let off gas, and that will ultimately make a fingerprint visible. And you can preserve it for later use by treating it with starch, because when iodine comes in contact with starch, it turns a purpley black color. 9-hydrin we will not necessarily be using in our classroom. It is very suitable for porous surfaces like paper, tissue, and clothing. It reacts with amino acids, which are basic monomers of proteins that are present on your fingertips to form a purplish blue compound. So again, we won't really be doing this. You soak things in a solution, you let it dry. Sometimes there's a spray. You might not be able to see that based on my camera here. I don't know if I can move this. Hey, there I am. So you might be able to spray it, and that will leave the fingerprint to be visible. Again, it's not ideal for us in terms of the work that we're doing in this class. I'm going to move them back because I like myself over to the right here. Okay. Another one that we will not be doing is silver nitrate and UV light. Again, very suitable for porous surfaces like paper and drywall. When you expose the surface to UV light, the silver nitrate will react with the salt and the sweat to form a black or brown compound. So obviously it is light sensitive and it is insoluble in silver chloride. So it will sort of react in that way. So we would spray it with the silver nitrate solution, expose it to UV light, and ideally see a fingerprint. There are some other methods as well. There's a lot of advancement in this area because fingerprints are incredibly useful to forensic science, special brushes, new chemical procedures. You've noticed that a lot of this has to do with chemistry, right? What's going on at the molecular level in terms of what our bodies leave behind at crime scenes, and how can we take advantage of chemistry to expose those prints and those traces of human product. And there's many, many different methods to develop fingerprints, and it really depends on the surface being examined. Okay.